Okay, we're going to work textbook problem 226. We have a car leaving skid marks 92 meters long, and we're going to say that we know its acceleration. We're going to try to estimate or figure out the speed of the car before the braking was done. So this is a little trickier because they're giving us the area, but that's alright, we can still work it out. So we have an unknown VI. We know that we're ending with a VF of 0. Our V is going to decrease linearly because we're at CAPM. We know our acceleration is going to be negative 7 meters per second squared. The negative because I've called my VI positive, and so the acceleration must oppose that if we're going to slow down. We don't know the delta t. What we do know is that the delta x, which is this area, is 92 meters. So we can write an expression for that area. It's a triangle, so it's 1/2 times the height of the triangle is just VI, and the base of the triangle is delta t. So we can solve for that delta t, for the VI, though we don't know the delta t yet. So 2 delta x over delta t. Okay, so we know the delta x. We do not know the delta t. We do know the a, however. And a is the slope of the velocity graph. So a is VF minus VI. VF is 0 over delta t. So delta t is negative VI over a. I can combine that there. And I get VI is 2 delta x over negative VI over a. So I'm going to bring this a up to the numerator to simplify the fraction. So this is going to be negative 2a delta x over VI. I'm going to multiply the VI up to the other side. So VI squared is negative 2a delta x. VI is the square root of negative 2a delta x, which is the square root of negative 2 times negative 7 meters per second squared times 92 meters. Good thing that was we figured out that was a negative acceleration. Otherwise, we wouldn't have a real answer here. So we plug those numbers in, and we get 35.9 meters per second. The units worked because I took meters per second squared multiplied by meters. I get meters squared per second squared to take the square root, and that's meters per second. This is pretty fast. This is well over 70 miles an hour. But, you know, they're long skid marks. It's almost, it's about a football field long skid marks. We have to make sure that we make the right choice on the sign. When you take a square root, there's a plus and a minus root. You have to make sure you know which one you want to get. Here we want the positive root because we decided our initial velocity was positive. Okay, algebraically, we start with a diagram. We have an unknown VI. We have a VF of 0. That happens over a delta x of 92 meters. Okay, if these are positive, that means we've taken positive to be to the right. The acceleration must therefore be to the left. It must oppose the velocity if it's going to slow it down. And so that would put it in the negative direction, given our choice. Delta t is unknown. The model we want here is this one. And we know VF is 0. So I solve negative VI squared over 2a. I'm sorry, we're looking for VI here. So VI would be equal negative 2a delta x square root. Solving that, which will give us the same thing that we got over there.